everyone, and welcome to today's presentation on gas distribution systems, brought to you by Swagelok, Indiana, Cincinnati, supplier of critical fluid systems throughout Indiana, Central Kentucky, and Southwestern Ohio. I am your host, Jorge Jimenez, Director of Sales here at Swagelok, Indiana, Cincinnati, and I'm joined today by two leading subject matter experts, Mr. Karim Mahraz and Mr. Joe Rodriguez, who have kindly offered to present today's webinar. This session will be recorded, and we ask that you please mute voice and turn off camera to ensure optimal sound quality. We highly encourage everyone to ask questions throughout the presentation, and you can do so by clicking on the Q&A button and typing your question into the chat box. Mr. Mike Peckrell, our resident field engineer, will then address your questions to our presenters. I would also like to point out that we will be raffling off a Swagelok Yeti 10-ounce tumbler for everyone that submits a question during the presentation, and the winner will be notified directly via email. So for now, let me hand it over to Karim and Joe to walk us over the presentation.
All right, thank you, Joe, for the invite and the opportunity. Again, my name is Karim Mahraz. I'm the product manager for analytical consultation and custom solution with Swagelok. I've been with Swagelok for 13 years and held multiple roles across different service groups, starting manufacturing and moving to custom solution. And in the last 5 years, I spent it in marketing as the product manager for general industrial product like the valve and the regulators. And also, I'm leading now the analytical consultation along with the custom solution service groups.
Good morning, everybody. My name is Joe Rodriguez. I'm an applications engineer in the Custom Solutions group here at Swagelok. Like Karim, I've also been around for 13 years in the company, and I've also held multiple roles before coming into Custom Solutions. I was previously in our product development group, as well as our test lab.
All right, I think we can start with the content. So currently, or the agenda for today is to go and discuss a little bit of what's a distribution system or gas distribution systems. And then we will highlight some of the importance of these systems and the role they play within certain applications, the benefit and advantages of these systems that they provide to the application, but also to the operations. And also we will highlight some of the regular basics. And then my colleagues, Joe is going to highlight some of the design standards and what we call best practices. And then lastly, we will take on any questions that you guys might have. All right, so let's start by looking at what are gas distribution systems. So gas distribution systems play crucial roles or functions for many industries. These systems work to deliver gases from a high pressure source to the facility at a pressure rate required by each of these applications. So the systems are designed to provide precise and safe delivery of high pressures, toxic, corrosive, or flammable gases in some cases. There is a lot of places and industries where gas distribution systems are used. These gas distributions is crucial functions or play crucial functions for many industries, research, operation, and production facilities. As an example, nitrogen, helium, and hydrogen and/or air are carrier gases commonly used within gas chromatograph, for example. And the purity of these carrier gases is crucial. So the gas sensors within these refineries, and specifically the analyzer, can occasionally drift from its specification. And the calibration gases play crucial roles in restoring that accuracy of the detectors through frequency and proper calibration. So it's crucial to maintain kind of the purity and of delivering these gases to certain equipments. So gas distribution systems can play different functions and be used for different purposes. Customer may have a need to use gases panels based on applications, the functions and need. And to list a few of these usage of these systems, they can be used as an access point for gas supply, maintain the purity of the quality of the gases, reduce the source pressure to a lower pressure or constant pressure, enable an uninterrupted supply of gases. But also it can also play a crucial role in handling these reactive or toxic and corrosive gases. And in some cases, like in semiconductor, they can also handle like these expensive high purity gases. So when the systems are inured, or when we endure issues with the systems, it can really result not only on the loss of gases, but only on loss of efficiency of these systems, and it can affect downtime, safety, and safety. So when systems operation is not intuitive, when leaks are a concern, or when gas panels are difficult to service, it's time to take a closer look at and take some actions to kind of address these challenges that you're facing with these systems. So safely, reliably, and effectively delivering gases to where they need provide the foundation kind of to well-performing operations when you use these gases or these systems. There are some definite advantages that the gas panels offer for any customers within their operations, applications, or in industries. First and foremost, they need to ensure the safety. Designed with the safety in mind, these systems need to ensure the safety and well-being of the operation as well as the team members. Additionally, these systems need to be designed and labeled to be both easy to understand and safe to operate. They improve also the uptime and reliability, and that's by these systems are always intended to help maximize the gas usage within their applications. They support increased uptime and improve the process accuracy and the repeatability. Also, the third aspect is they save you time and resource. So when they are fully assembled and tested prior to being installed, they ensure the reliability of the performance of those systems and let you focus your time and resource where you need them most. So the reliability of these systems can also lead to a reduced need for maintenance and saving you additional time and resource that you have to spend on maintaining them, but also servicing them. Reduce the cost, and that's the last element there, by avoiding leakage and unplanned maintenance. So they should be easy to maintain and troubleshoot for the operator. So let's look at some areas where we feel there is a need that we need to pay attention to with these systems, but also how they fit into those four segments that I just shared previously. So something usually taught in school, we call it the fire triangle, and also known as the combustion triangle. It's a simple model for understanding a chemical reaction which must occur to create a fire within a gas distribution systems. For example, let's consider oxygen. So the primary hazards for oxygen are the high cylinders. So those are typically in the range of 2200 psi to 3600 psi. And gas pressure systems are built with material such as brass, copper, and in some cases stainless steel, and also soft seal materials like Teflon, etc. All of these are form of fuel in an oxygen environment, but by its very composition, an oxygen gas handling systems has already two of those required three legs that you see on the triangle of the fire triangle, and namely oxygen and fuel. So the safety of the operator and your plant or facility will depend on your ability to control the heat or the ignition source for these systems. So as such, these systems need to be kind of designed using safety in mind by selecting the right material, using high quality cleaned. They need to be maintained at certain cleanliness level, leak tight, then tested prior to installation to help ensure less time needed for troubleshooting and ultimately improve the safety of the operator and the plant itself. So changeover systems, that's another one that there is a misunderstanding of what's a changeover. There are two types of changeover. The first one is what we call a manual changeover, and that provides a continuous supply of gases to two or more sources container. There are two types, as I mentioned. The manual one over are typically systems that need to be operated manually. And to enable the switching mechanism, as you can see in the illustration here, this system typically has several downsides. Need to manually kind of reset the valve when the first bottle empty, opening and closing the isolation valve to kind of disconnect the cylinders. More time consuming. It requires a lot of involvement from the operator to go on the field and make sure that they change the bottle, but also to switch to the second source. Risk of running out of crucial gases. So the intent of these systems is to continuously supply your operation with the gas. So it really doesn't do its function when you have to manually go and change it. And can lead also to premature changeout because you have no indication of when the change needs to happen. So you rely on best guess, I should say. So they require more involvement and monitoring from the operator. So the second one, which we call an automated changeover, you can rest assured that the first source will be depleted without the concern of premature changeout. Wasting or having gas outage is not an option in this typical configurations. And when one source empty, the changeover system will automatically draw from the second source, and the first source can then be changed out without interruptions of the outlet pressure. So the third element that I wanted to highlight, which is the filtrations. So as we all know, there is an increase in use of all type of gases, and that has been mainly driven by the process requirements for all manufacturing, and also the processes. In order to achieve and maintain the system integrity and performance, the selection of appropriate filter is absolutely essential and crucial for maintaining an operation of these systems. So the main source of particles are industrial gases components used within these systems, such as the check valve, fitting or threads fittings, ball valve, tanks, and pumps. But in some cases, it can be also the environment where they are installed can cause or can lead into particles. Though they are crucial to the process, these components may release these particles through the installations as they were. So when dealing with filters, there are a variety of options that you can have, certainly, but there are some criteria that we need or we feel we need to pay attention to when choosing a filter, such as the filter component, the element, the material, the housing. As such, we need to keep in mind that the selection of the filter need to match the task at hand. Also, in general, regulators are susceptible to damage from system particles. It's important to look closely at the design of any pressure reducing regulators, and at a minimum, they should be equipped with some sort of element, as you can see in the image. Usually, they can be press fitted. A best practice is to install a filter upstream to protect the component, but also the system integrity. So let's take a look at some of the basic fundamentals of gas distribution systems, and specifically a key element or a product in these systems. So the regulators. Regulators come in all shapes and sizes, as you can see in the images, but there are a few terms and definitions that we feel are important to understand and look at closely when dealing with gas systems. So these regulators play crucial roles in the systems and are not easy to describe in one sentence. The key word that we need to keep in mind is pressure. So a pressure regulator is a type of valve that controls the pressure of a fluid or gas to a desired value. Regulators are used for gas and liquid and can be an integral device with a pressure sensing, a restrictor, and a sensor, all in one body, or consistent of multiple components separately to achieve the pressure reducing element. Something to keep in mind when dealing with regulators is that there are two types. So there is, when dealing with downstream pressure changes, those we are or you are required to control them by what we call a pressure reducing regulators. But the upstream pressure are controlled by a back pressure regulators. As I mentioned, when dealing with gas panels, we need to correctly select and size the pressure regulators because it's a crucial component and of a properly functioning gas distribution systems. These aspects of performance that are important or mostly important when choosing the pressure regulators for one of these systems are kind of like you have to look at the droop, the lockup, the seat load, the choke flow, and supply pressure effect. So a lockup is the difference in pressure between a flowing and non-flowing conditions. So when flow stopped at an outlet pressure, as the outlet pressure built, the balance force favored the control element, which allowed the poppet to seat itself, excuse me, and close off the inlet pressure. The second one, which we call the droop or a flow effect, droop is the reduction of outlet pressure experienced by a pressure reducing regulators at a flow rate as the flow rate increase, and that's kind of the ideal area where you want to maintain the regulator performance. And the last one, which is the choke, it's when a regulator is fully open in the open position and it's no longer kind of doing its function, it's acting like a normal valve, just fully open and not controlling the pressure. So now that we understand some of the design characteristics, along with some of the decision factors, I will hand it to my colleague who will give you a closer look at our standard design, their design benefit, and some of what Swagelok considered the best practices for gas systems.
Asking for a change in slides from time to time. We'll begin with a breakdown. So for defining our gas distribution systems, we decided to break it down into 4 separate subsystems, and we'll go into detail a little bit on each of those and how they interplay with one another. We begin, as most gas systems do, at the bottle that's supplying all the pressure. So we have a system specifically targeted towards this. We call it the source inlet. The real goal of this is just to connect your bottle to the rest of the gas system. As we were designing, we discovered that there was a great need for a lot of flexibility here. So this one will have various options for connecting multiple bottles or single bottles, manifolding them together if desired. It will come with various options for isolation, excess pressure relief, venting, and critically, as Karim was mentioning before, filtration. As we all know, any sort of regulators or pressure dropping devices are going to be sensitive to having debris crossing them. So filtration is included in the source inlets right up front to make sure that the rest of the system stays as clean as possible. So I think that's just about it for the SSI. So the SSI will commonly feed one of 2 separate panels. The first is the standard Swagelok gas panel, or SGP. This is really your primary pressure regulation stage. These are available in either 1 or 2 stages of regulation. The 2 stages of regulation can be very desirable for helping with excessive Joule-Thomson cooling and helping mitigate the supply pressure effect to maintain a steady line pressure on the outlet. These are all going to be wall mountable, and they'll have various options. Obviously, pressure monitoring with gauges is going to be critical on all of them, but they also have various options for overpressure relief, venting, and outlet isolation, which is lockable. Very nice feature for performing maintenance, adhering to lockout tagout procedures and the like. And these are also available with different types of regulators. So if you want a two-stage regulation for maintainability. Sometimes it's nice to have two separate regulators for commonality of parts, as shown here, but these are also available with our KCY regulator, where you have two regulators in a single body. The main goal of the SGP, I should point out, is although it is available with some of the lower pressure ranges, very commonly, feedback we've gotten from customers is that this is useful for dropping your bottle pressure to a supply line pressure that you'll be, say something like 30 or 40 bar to be distributed to other points in your plant, like a point of use. Moving on to the changeover, or the SCO, as this fulfills the changeover function that Karim was describing earlier. This is accomplished by having two separate inlet sources, each feeding their own regulator. And these two regulators are set up at a differential pressure such that when the primary gas cylinder that you're drawing from reaches the changeover pressure, it'll automatically and seamlessly start supplying from the secondary source cylinder. So the SCO is able to have either the left or the right side cylinders be selected as the primary source for some added flexibility. And they are also available with the same options as the SGP. So you have overpressure relief, pressure monitoring, and outlet isolation. And they're also available with or without a downstream line regulator. Moving on to the point of use panel, this will typically be the last regulation stage before you're actually going to supply the gas to the device that requires it. So as Karim pointed out, common applications will include things like lab equipment, process gas analyzers, things like that. So this is intended to take your line supply from typically an SGP or an SCO and reduce the pressure to the pressure that's required for that piece of equipment. This one is going to look up and feel a little bit different than the others, but ultimately it's still a regulator panel. So it'll have some slightly different features. You'll notice it's fairly narrow. These are designed so that in the event that you need to have several different gases available, say in a tight lab situation, they can be stacked very close to one another to minimize the footprint. They're also extremely flexible in the mounting options available. You can mount them to walls, 80-20 that you've got up on the walls, above and below benches. Really intended to be flexible that way. Critically, these are also available with filtration, kind of a last step filtration to make sure that you're protecting anything that you've got downstream. Typically, there will be some sensitive or some occasionally some very expensive equipment that these are feeding. And it's important to make sure that the gas is clean as it's being supplied to them. So one of the things that we wanted to make sure that we were supplying for these, as we begin to standardize these sort of gas distribution systems, is these are available with users manuals. It's very easy to generate sales and as-built drawings for them. And you'll see the drawing example here even comes with a complete bill of materials. And the way that these are configured, it's also very easy to provide a spare parts list, so you guys can have all your documentation ready at hand. Here's a couple of clips from our application guide to assist with the part numbering. You'll notice all the various options are easily break down, just like any of our regulator catalogs, those who are familiar with those. And we also have our sales and service centers have been equipped with some factory developed tools to assist with creation of these designs.
Awesome.
Yep.
Thank you, Joe, for the insightful update about the systems. I just wanted to share some details on how kind of we went by developing the solutions, but also what's the training and that most of our sales and service center go through before they are able to design the systems. Also, it's more of us doing the training needed to support the development of these solutions and be able to customize them locally. So we currently have what we call a certification program. So as Joe and the team mentioned, we develop these solutions. We don't want to just kind of push them and sell them. There is a training that needs to take place before any sales and service center are able to kind of assemble but also configure these systems. So with the certification program, our sales and service center go through an extensive training on the design aspect, the theoretical aspect also of these systems, and to be able also to design them, but also to make changes that the customer might have. So after they go through those certification, they go through extensive training, then they are granted kind of the certification aspect where they can start kind of building these systems and working with you by utilizing some of the tools that Joe has mentioned, that we have developed to help kind of speed the process in providing you with the solutions, but also making the changes needed to give you the best solutions for your applications. We use standard components to build and design the systems, and we use also local engineering resource that you can work directly with our sales and service centers. And lastly, if needed, if there is applications that are kind of very unique and very challenging, we certainly can tap into our engineers here at the factory, where they can assist with making the right assessment for that applications and recommending the solutions. So after the certification, we kind of build that expertise and we bring it all together. There is a local support that you will have constantly from our sales and service center. They all went through that training, so they have built their expertise to be able to design the system, but also understand and assess your applications. All of these systems have been integrated with best practice from our standard designs. So because we have about 70 years of experience in analytic consultation, but also all these applications that go along with it, we have developed what we think it's best practice and the best designs that are available out there. These systems have been kind of designed with the safety in mind, but also they are effective at delivering the gases or that's needed. They also, we have integrated them with best practices like we shared through the filter, through assessing what the gases or the media that's being used with them. They can be adapted to meet any requirement. So what you see there is not exactly what you don't want. We can certainly make those changes and adjustments to the system to make it fit exactly what you need. So don't think that everything that you see there is exactly what we can offer. That's just a fraction of what the team can do and also support. They are easy to install and operate, and that's what Joe went through. There is a documentation that's very crucial that we feel is necessary with each of these systems to help facilitate the interaction between the operator and the system, but also when service is needed, you have kind of the whole package that's needed to service the panel properly. They are also easy to maintain by making any changes or service for the component itself. The part numbering aspect, and Joe touched on those things. So the part number is very unique to Swagelok, and if you can rest assured that if you order a system here, that if you spec that part number, you can certainly get it anywhere in the world the same way by working with our sales and service center. And all these systems are backed by Swagelok limited lifetime warranty. So rest assured that we will back these systems and we stand behind them. So that concludes our training, and we'll be happy to take any questions that you might have.
Yeah, we have a question that came through the chat. I saw options listed for oxygen and for inert gases. What about flammable or toxic gases, i.e. sulfur, chlorine mixes?
Okay. So for most of the flammable gases that you'll commonly see, you should be able to use one of the inert system designs that's already available. Typically, what you'll need to look at is material compatibility. So, with any of the soft goods that are in there, or any of the stainless steels. So, if you've got something toxic or like a chlorine mix that's going to be potentially corrosive, that'll have to be addressed. The standard designs available should suit the majority of applications, but if you do have a particular need, a toxic gas that is not able to work with one of those, the gas distribution program serves mostly as a design platform, and so your local sales and service center should be able to assist you with a custom design that is able to suit your individual application.
And another question, are alarms available to provide notification for changeover systems to alert that cylinder has been emptied?
The standard designs are not configurable with alarms as such, but we understand that there's a lot of customers that like to have that sort of functionality, and so there have already been a number of requests for including pressure switches for alarms and the like. And once again, the gas distribution program is intended to be highly modifiable, so it's really not a big deal for those to be added to one of the standard designs at request.
Yeah, and I'll just add that we have done quite a few automated systems, and we can certainly, or our sales and service center along, if they need help, we can certainly integrate some of the automation aspect to provide feedback that's needed for those systems.
And to follow up on the second question, that Clarion, one of our customers, we have a mandate for use an excess flow valve at the source in case of a line rupture inside of the building. What does Swagelok offer for excess flow valve safety? Not mandate requirement.
Karim, I'm wondering if you're a little bit more familiar with the excess flow valves than I am, but I'm pretty sure we have one in our catalog, and it should be a fairly simple matter to add one to your SSI if you have to have it very close to the source.
Yes, certainly. We can certainly integrate any safety component that you might need. We have certainly the access flow valves, but also even if you have something that you have used like a specific third party, and that's something that we missed to highlight, is that we can integrate other components that not even our Swagelok within our systems to give you the functionality and that meet your requirements. So there are some that we have done in the past when we have used some access flow valve based on the applications and the customer requirements, and we can certainly make those changes and adjustments.
Okay, and can you explain more about the flow curve for a regulator, specifically during lockup? In the example shown, what would happen, and it gets a little detailed here, what would happen if my flow was 5 cubic feet per minute, or I try to set an outlet pressure of 75 psi? If this is too detailed, I can reach out to this customer and go through those details.
Yeah, and certainly, yeah.
Go ahead.
And certainly we have kind of additional training for regulators that's going to what we call the high level overview of the regulator, the functionality, and the flow curves. But also we have in-depth training that's go and describe all of the elements that I shared with you guys earlier with the lockup, the droop, etc. And we can certainly help explain that in details those elements and what drive or what caused them, but also how to address them and mitigate them. So certainly it's a great question, and happy to go into more details and discussion if needed and follow up.
Sure. And can you benefits, drawbacks of a single body, 2-stage versus 2 separate bodies?
So the question was, is there a difference, a functional difference between having two separate regulators for the double stage regulation versus a single body? Functionally, they're going to be equivalent. Yeah, the first fixed regulator stage is going to be the same for both of them. The internals are the same. You know, there's there's functionally there's no difference. I think we implemented both of those because we do have a number of customers that are already using the single body solution, and they're very happy with that. We also heard that there were other customers that would prefer to have two separate ones, and so yeah, that's more or less a decision to help aid with particular preferences.
That seems to be the questions we have from the chat for right now. Oh, one more. We have some hydrocarbon mixtures which drop in temperature with a drop in pressure.
So are we talking about, we're talking about gases that have a lot of Joule-Thomson effect happening?
I believe so.
Okay. So typically the way that you want to handle those is you don't want to drop all of your pressure at once. You want to sort of drop it progressively. So you'll want to have at least 2 stages of regulation, sometimes even more. And the idea is you'll incur your pressure drop and your temperature drop, and then in the span between those 2 regulators, there will be an opportunity for the gas to warm up slightly before the next pressure dropping event. So that should help keep the regulators from freezing up.
I've got some more questions coming through here, and I think that's he was following up. Is 2 separate regulators better than one? And I believe the answers would be yes. We'd reduce that Joule-Thomson effect. Can you touch about the maintenance friendly aspects of the design of the panels?
Yes, absolutely. So if you look at the designs of those panels, the images that we were showing you as we were going along, all of the flow components are prominent. They're front and center. So it's easy to see where everything is connected, and they've been designed such that you can get wrenches on all the fittings, and everything should be more or less modular and be able to come apart and be easily accessed without having to completely disassemble the whole system out of your installation location. There's also some little features. For example, the regulators are bolted to the main panels using a separate spacer bracket that has keyhole slots in them. So once you get the fittings disconnected, you sort of just loosen those bolts and they should lift out. This is something that we did, as a measure of implementing customer feedback. We do have other changeover regulators that we offer. I think the KCA is one of them that comes to mind, and that one it's a very nice looking unit with sort of a panel covering everything, so all the piping is at the back. And again, one of the pieces of feedback was if we can take all the piping in the back and move it to the front, and give everybody access to everything, if a regulator needs to be maintained or something like that, then that would be desirable for that standpoint. So that's kind of how we try to implement it.
Okay, thank you.
All right. So the last. Is there any other questions?
There's no more questions. Thank you.
Okay. So just a quick tools that are currently available on product and services that support this program, and certainly you can go to these links that we have to get a quick look at all the gas distribution program. We call it the quick look. that highlight some of what we went through today. Also, the applications guide that Joe has shared with you guys and alluded to, that has more details on the system themselves, the functionality, but also the part numbering and everything that you need to know about each of these systems. And also we have some case studies that we have developed through some customers. So you can see some of the successes, the story, and how we helped the customer address some of the challenges. And lastly, something I wanted to highlight is there is the field engineer or advisory service that we have developed as part of this program, where our field engineers through the sales and service center can come to your facility and look at closely all your systems and make recommendation and assess these systems on the functionality level, the efficiency, and they provide you with a report that has some recommendations and details on how to address them. And certainly, if there is a need to follow up, we can certainly look at closely and provide you with design enhancement to these systems.
Yeah, thank you, gentlemen, for sharing your knowledge. And I wanted to thank everyone who attended today. So from all of us here at Swagelok, Indiana, Cincinnati, we look forward to having you join us again for our next webinar, which will be on Regulator Basics Part 2, and will take place on March 18. So please keep an eye out in your inbox for more details. Thank you very much for your time.